Why is orbital insertion crucial for space missions? Imagine sending a spacecraft thousands of miles into space, aiming to study distant planets or relay signals back to Earth. How does it stay in just the right spot to do its job? That's where orbital insertion comes in. It's the key step that turns a passing spacecraft into a stable satellite or probe. Without it, the mission would be lost in space or crash onto a celestial body. When a spacecraft reaches its target, it's usually traveling at very high speeds along a trajectory that will cause it to fly past or even crash into the planet or moon. To stay in orbit, it needs to slow down or change direction at just the right moment. This is done by firing the spacecraft's engines in a carefully timed burn. The goal is to adjust the spacecraft's velocity, which is called delta V, so gravity can take over and pull it into a stable orbit. If the spacecraft doesn't perform this maneuver correctly, it might escape into space or fall onto the surface. Small errors in timing or engine power can cause mission failure. That's why precise calculations are essential. Engineers analyze the spacecraft's position, speed, and the gravity of the target body to plan the exact moment and amount of engine burn needed. Sometimes, multiple engine burns are necessary to fine-tune the orbit. Orbital insertion isn't just about entering space. It's about entering the right kind of orbit. Different missions need different orbits: low Earth orbit for observation satellites, geostationary orbit for communication, or highly elliptical orbits for scientific studies. Sometimes, aerobraking techniques are used, where the spacecraft dips into a planet's atmosphere to slow down and refine its orbit without using extra fuel. Once in orbit, the spacecraft can perform its main tasks. It can take pictures, collect data, relay signals, or even prepare for landing. Achieving a stable orbit allows the spacecraft to stay in one place relative to the planet or moon, making long-term observations possible. It also helps conserve fuel, which is limited and expensive to carry. In the end, orbital insertion is what transforms a simple flyby into a long-term presence in space. It's a complex dance of physics and engineering that makes space missions successful. Without it, exploring distant worlds or maintaining satellites would be impossible. It's the moment that makes space exploration truly happen.